Welcome back, people, to this video following on from the regions on Cartesian planes. This one looking at those examples and showing you how all of this actually works in a bit of practice. Our first example here, we're going to jump straight in. First example, shade the region for the following linear inequalities. First inequality there, looks like our y equals mx plus b format, so this one's going to be quite easy. We've got y is greater than 1.5x minus 3. So we can do a couple of things. We can just use our gradient intercept form and information to draw this line and then graph the region. So I know that my y-intercept is at 3, or at minus 3 rather. Minus 3 is my y-intercept. Okay, now I know my rise over run is 1.5. Or that could be put as 3 over 2. So for every 2 across, I need to go up 3. So if I go across 2, so 1, 2, I need to go up 3. So 1, 2, 3. And at that spot, well, that's at 2. And now I can draw my line. I can use my trusty ruler. Line up those 2 points. And then I'm going to join them with a line that goes through them. Now, before we draw the line, I do need to pay attention to the sign. This is just a greater than sign. It's not an equal to, so my line needs to be dotted. Dotted line to indicate that no, those values won't satisfy the equation itself or the inequality. However, all the values above it will. So I can shade all of the area on my graph above the line there. So I just use my little highlighter there and only shade up to the line. So then all that shaded region can satisfy my inequality. Now the next one needs to do a little bit of rearranging. So I want to rearrange my equation so that I can make it look like y equals mx plus b. Alright, so that's going to end up being y is less than or equal to minus 2x plus 4. Alright, gives me a y-intercept of 4 and a gradient of minus 2. So for every one across, I've got to go down 2. So let's pop in some bits of pieces. There's my 4. And let's see. This time I need to go across 1 and then down 2. So I go across 1 and then down 2. I can do the same thing again, across 1, down 2. Gives me that intercept there of 2, and I can use my trusty ruler again to line up those 2 spots to draw the line through. Now, just to remember, for this one, our sign is less than or equal to. Less than or equal to. So for this one, I can actually draw in a solid line. There's my solid line. I just put my 2 out there, my 4 out there. Get them out of the way. Whoops. There we go. Alright, so now I've got my solid line and I can shade in. This time I want to shade under the line. Okay, if it's under the line, it's going to be under here. Now it kind of looks like it's on the same side when you look at it, but no, it's definitely on the underside of the line this time. Okay, so now all that shaded region can be used to satisfy the equation. Alright, hopefully this is giving you a bit of an idea of what you need to do. For our next one, we're going to do an intersecting region. We're going to use 2 equations in the next one. Alright, so we want to sketch both these equalities on the same set of axes. Okay, but what we need to do is we're going to find some intercepts. And easiest way to find intercepts is to substitute in for 0 for each of those values. So let's get started. Alright, so that's what I'm going to do. I'm going to sketch each equation or inequality by finding the intercepts. Okay, so the x-intercept and the y-intercept. Alright, so let's do the first one. We have 4x plus y is less than or equal to 12. So what I'm going to do is I'm going to make that an equation rather than inequality and substitute in 0 for my 2 variables, but I'm going to do that one at a time. So first I'm going to let x equal 0, and this will find me the y-intercept. This one actually turns out to be pretty painless. This is my first y-intercept. Is y equals 12. So this is going to make this a very interesting looking graph. Next, I want to rewrite my equation. And this time I want to let y equal 0, and this will get me my x-intercept. Alright, so let's do it. 4x plus 0 equals 12. X equals 3, that's my x-intercept. Alright, let's do the next equation now. This time we've got 3x minus 2y is less than minus 2, no, or equal to for this one. Same process. Let x equal 0 to find the y-intercept. And y equals 1, because minus 2 divided by minus 2, well, that's 1. So that is our y-intercept. Let's do the next one. Same process as before, only this time I'm going to have y equals 0. So now it's a minus 2/3 is our x-intercept. And now we need to take that information and pop it on a graph. So here's our graph. Now, I am going to use a pretty wide scale for my x because the furthest away I need to get is 3. So I can put in so I can put in that. But I need to have a slightly more compressed version for my y's. Alright, so I'm just going to go up by 2's this way. So it's going to be 2, 4, 6, 8, 10, 12, 14, 16, because I do need to have a 12 in there. I need to go to 3, but on this side I only need to go to minus 2/3. Alright, and I don't have any negative y-intercepts, so I'm not going to worry about squeezing in any numbers down the bottom. Alright, our first pair of points, that was y equals 12 and x equals 3. So y equals 12 and x equals 3, and I'm going to bring up my ruler. And for this one, I actually have the opportunity to put in a solid line because this one is the and equal to, or equal to, I should say. So there's that one in, nice and solid. Alright, I don't want to shade yet because I'm doing an intersecting region, not just two regions. Now the next one, the values are 1. So I'm going to go about halfway there and minus 2/3. So that's going to be this spot right there. Now you can see they're quite close together. And if you've got the opportunity to draw on a bigger graph, I suggest doing it. And so we line that up. Now this is the only less than. It's not less than or equal to. It's just less than. So this one is a dotted line. All the way through. Okay. Now, where these two regions overlap is the region we actually want. Okay. So the region we actually want is going to be this one right here. Because you can see that's actually where they overlap. That's our intersecting region. There's our intersecting region. Now that is our intersecting region, even though it doesn't kind of look like it. It is the region because we can test for the origin. Alright, so that test for the origin that we did before, that demonstrates whether or not the origin is in the region or not. And in this case, origin is not in the region. Alright, so that's why it looks a little bit wonky. We're not including the origin. And that point of intersection, so we have the shady bit. Well, that's our intersecting region. And then because we have a spot there on our graph where we have a point of intersection, because we have a sign that is not or equal to in there, we're going to use an open circle to represent it. And then we're going to label it. And then we're going to put down the coordinates of it. So this one is at 2, 4. And that's it. That's how the regions work. Those are our examples today from our Cambridge textbook. Hopefully they have given you a bit of a hint on how to work these out. Good luck with all of your questions and thank you for watching. See you in the next one.